It's always, I'm not managing to my wonderful MacBook. You all love it. Where is that? Present. Present. Good. So, yeah, cool. So, good day everybody. I'm Valentine Gogichashvili. It's a very simple name. And I will be talking about, so you can see how it is written. It's very simple. I will be talking about microservices at Zalando. How many of you do not know what Zalando is? Okay, good. How many of you actually bought anything at Zalando? Aha, nice. It's actually about 10%. Good. So we are quite big, and we became big not so fast. We started growing. Actually, Zalando is around 7 years old, and I started at Zalando more than 5.5 years ago. So I'm a kind of a dinosaur at Zalando. So we started at Berlin. Now we grow. Our technology department grows, and not only technology department. So now we actually have. These are only the technology hubs of Zalando. And the technology team grows really fast. So now we are 1,200. I think 2 months ago it was 1,100. So we're really growing fast. But it was not always like that. I mean, we grew fast always, but we were not so big always. So we started as a small prototype, and the prototype looked like this. So we used PHP, we used MySQL. You probably know this. This is typical way to start the anything actually. But this model didn't really work for a long time. When I started at Zalando 5.5 years ago, the site was growing with the kind of 100% per month. It was quite an interesting time. We were actually the biggest users of Magento at some moment, and then Magento just didn't work anymore. So we decided to do the reboot. So it was a cool project. I started a little bit later when it started, and I was working for 5 weeks without weekends. It was a cool time. What we did, we actually rewrote everything in Java, used Postgres and stored procedures there. So I'm talking about this. I was talking about this on different conferences. If you have any questions, I can answer them. And used Python for automation. We automated as much as possible because with these growth, and so it's you need to automate. And Python was chosen as the language of choice for automation purposes. But now we're growing, and so again, history and context. We built the world of microservices. So microservices were not so small as microservices are supposed to be, but it was not also a huge monolith. So we've done our job not bad, and the system was very efficient, and it still works and still generates this 3 billion in revenue per year. But we have a problem. We had a problem. So our developers started to want something more. They want something cool. They want something exciting. We had the problem of, as you call it in corporate language, unwanted attrition. People started to leave. So what we did, we announced radical agility, so-called radical agility. The idea of radical agility that teams are getting autonomy, they get purpose, and what else? Yeah, and they should achieve mastery. What does it mean actually? This means that autonomous teams can choose their own technology stack. Autonomous teams are responsible for what they do. We decided to move away from our data centers into AWS. I see some smiles already in the audience. Actually, you probably understand what kind of problems we have, and started to see. Actually, this talk is about problems and how we try to solve them. So, autonomy is not anarchy. And to support autonomy, you have to work hard. You need to have an army, you have to have police, you have to whatever, it's kind of... so one of the pillars that we used to support autonomy of the teams was Stup's infrastructure. And on this picture, it looks very simple. Yeah, we use Docker containers, everything is cool, blah, 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 how it looks in reality. So this happens when you try to be consistent and be, how do you call it, compliant with the audit requirements from the German authorities. Yes, so Stups is the system for responsible corporations that want to run their business in AWS. This is what we managed to create to kind of the minimum amount of components and infrastructure that we have to do to ensure that everything that we do, everything that we run in production is auditable, everything is fine and cool, and we know who is doing what and so on. And another point was that we said, we will use microservices. What is inside the microservice, we don't care. The most important part is REST API and kind of that these microservices collaborate with it, communicate with each other. The problem, of course, happens here with the ETL processes. What does it mean? I will try to explain now, again, going back into the history. And I will go to kind of classical history. So it's very simple world. So we have developers, DBAs, business intelligence. They all work. They know their roles. Developers bring data to DBAs. DBAs give data to analysts and data scientists. This is the classical world. So this is how our vintage applications work. And they work wonderfully because in many cases, developer teams even don't know that the data scientists and business intelligence are extracting data from their databases. And the reality is, of course, bigger. We have a lot of services, a lot of databases, and extracting data into the data warehouse. It has some disadvantages, it has some advantages, but still, even if it has advantages, it doesn't work for microservices. So, what is the data integration in the world of the microservices? So we have small microservices. They all have some own databases. We have happy developers. We have a little bit, DBAs not knowing what to do now, and we have business intelligence guys going crazy because they cannot access the data any longer. So one of the solutions that we have or suggest now is that microservices not only exchange data using just REST APIs, but they also exchange data using queues. So we are building some very thin layer of a Kafka or Kinesis, so it's kind of underlying system agnostic system broker, Nakadi event bus that is providing security and authentication, authorization, and kind of registration of the entities in the bus. and allow the systems to exchange data. Actually, this is the typical way how people want to develop. Actually, this is how I want them to develop it. I don't actually want people to use databases at all. The best persistence layer for your microservices should be the event bus. But I will not go into details with that because it's kind of there. I cannot talk about our cool projects that we did to support the wrong architecture. Yes, so, and the idea is that business intelligence can extract the data from our event bus, subscribing to everything that is flowing there, having access to everything. So what are the typical problems of actually writing events into the event buses? And these are problems that many developers do not actually understand very well. This is how people want to do it. So if the application has database, people usually tend to say, okay, we will write event to the event bus or to Kafka, whatever, and then we write to database. Or wait, we first write to database, then write to event bus. Yeah, so it's actually a problem. You need a two-phase commit and it will be slow. So and it's very difficult to implement correctly if you care about not losing changes in your persistence layer. So another way to do this that would be actually make your life much easier and let the people who care about the consistency of data in your systems sleep well is actually extracting data directly from your persistence layer. So what we did for Postgres, as actually not we of course, so the Postgres supports now from recent versions the extraction of data through the logical replication stream, and there are several products. The PG Logical is written by Second Quadrant. Bottled water is a Confluent product. Confluent was done by the guys who actually created Kafka. And Tavon that we wrote, it's a purely Python project to extract snapshots from the databases and push the snapshot into the queue. So this more or less to demonstrate it a little bit better. So you have the snapshot extraction tool, you have a logical replication extraction plugin, and you actually can extract the consistent snapshots and follow the changes afterwards using the using the logical replication extractor. So Python, wonderful tool for doing many things, including the prototyping. So you actually can play around. The PsychoPG, the more or less official Python driver for Postgres, it's not yet merged, but the pull request is functioning correctly, so you can actually check out and see how this thing works. You can actually play around with the changes that are flowing from the database. You can see them in the form of JSON objects on your actually real Python objects in your application. So it's really a cool thing. And I really, it would be really nice to hear your feedback about other projects that are related to this topic. This is mostly Python code. Another possibility would be if you're on AWS, DynamoDB has support for Dynamo Streams. This is more or less the same, but really working just by the click of the button, and you can extract data from kind of the stream of changes that happening to your DynamoDB cluster is actually pushed into Kinesis-like queue, and you can directly build your event-driven, wrongly built event-driven application using this technology. I wanted to put also the slide about Cassandra. Cassandra doesn't have this support, and there is the big ticket on this, on kind of recovery of data change events from the cluster. But because of the architectural problems, it's a lot of work to be done there, and I think they need at least a year or so to come closer to this kind of a solution. Okay, we have our bus, we have our, so how much time do we have? Oh, wonderful. We have our bus, we have, so now the question is, how do we actually transport data into our business intelligence or data science infrastructure? And this is Saiki. So Saiki is a crazy name. Actually, we call our projects quite crazy names because our teams also can use their own names, choose their own. We have Team Nobody, for example. Who's responsible for the product? Nobody. Okay, this is a team name. And Saiki is a Javanese, not Japanese, Javanese name for queue. And nobody knows if it's true because they used Google Translate for that. So. Yeah, Saiki Data Platform. Actually, Data Lake was invented by probably earlier. The Cranach actually made the first architecture diagram of Data Lake in 1546. You see here the queue of kind of messages coming into the purifying fountains, and then you have the analysts feeding on the data, everything fine, but we need a more modern version of this thing. So I will now explain a little bit more how the how Saiki works. So currently, Saiki extracts data from the data queue and puts it in another queue. I will cover this a little bit later. Why? Afterwards, they're pushing it into the Tukang system. This is also so all these names are Javanese, and I keep forgetting the meaning of these words, but you can look them up. So I checked that there are no swear words there. And Tukang is more or less the S3 materializer for data that is flowing into the event queues. So what Tukang does is it keeps track of the metadata, materializes data into the S3, and then allows more or less extracting this data from S3 using this metadata into the data warehouses. It also allows to create more materialization engines, like, for example, I already talked about it a little bit. It also cleans a little bit event stream, and then it also allows to materialize into different databases. For example, if you have something else, not the data warehouse system, but some smaller forecast system, you can actually fetch some parts of the data that is interesting for you. For example, information about prices or information about articles being changed or created, so products into something different. So you see that there is still place on this diagram, so more is coming. What are so if you compare the two processes, actually there are only advantages other than one point. Actually, it's very difficult now for the business intelligence people to really control the structure of something that is flowing. So we are trying to solve this problem by this Nakadi register of to enable to register the types in the Nakadi and then check that the types that are flowing into the event bus actually correspond to what is registered, but there are some problems and discussions about this types in Nakadi project. So you are really, so all these projects are developed open source. So you are really welcome to look into the codes, into the pull requests, and have your kind of ideas also given to us. So yeah, this trust for correctness of data on the delivery team. So we never trusted anybody before, and now we live in the world where we have to trust, and actually it makes people happier when we trust them, but we still have to check that they're doing their job right. What else? What can we do actually with the data from that we store there? So we also can actually produce, analyze the data in real time. So we did quite extensive comparison of two systems, Flink and Spark, for the reasons of processing data in near real time. And Flink won, and one of the topics where Flink won also was the reaction time for when we had problems. The community is really much faster than the Spark community. Yeah, actually I have a nice slide here, and also a link to the blog post on our tech blog about the comparison of Flink and Spark. So really, if you don't know what Flink is, have a look. If you know what Flink is, then actually next week there is a meetup at Zalando office about Flink. So you are welcome to come and listen to the guys who wrote Flink actually. Flink also, as Spark, of course, supports a lot of connectors, and you can actually directly write to Spark, to Elasticsearch system, for example, and the current implementation uses Elasticsearch. But the idea is that we not only use Elasticsearch and something else, so if we have the machine that is working there nicely, then we actually can enable data scientists to deploy code in the managed Flink cluster, and they will be able also to calculate and get some interesting insights from the data that is flowing real time from all the systems that we have. One of the use cases for real-time business process monitoring is, for example, you can really check that all the processes and business processes work as expected. You can, yeah, I already talked about it. I'm somehow talking a little bit ahead of the slides. Sorry for that. Yes. What else? And there's still space here. So actually, what can we do? So here, actually, the data lake. The idea is that S3 as just a dump of data is not enough. You don't want to build a data swamp. You need to have a data lake that you can actually be able to access afterwards. And the data lake project now has several prototypes of how to persist data into S3 so that it's then easily accessible through systems like HDFS or Hive or whatever. So now there are a lot of discussions in the team about these topics, and I will be really very interested also to discuss these topics with anybody who is also doing this kind of projects in their companies. Yes, open source, as I said, we perceive the idea that you should do everything open source that can be open sourced. And every time when the project is being started at Zalando, we more or less discuss, can we do this project open source? If we cannot do this open source, then we have to really find the reason why not to. What is stopping us? Yeah, so is it really the competitive advantage that we will be giving to somebody away if we open source this? So one, of course, has to consider all the possibilities and all the dangers for a commercial company, but we're really trying to do as much open source as possible. The very interesting part, especially for the Python community, I think, is this link with the connexion. This makes it possible to create microservices with RESTful APIs in a matter of seconds, just by defining Swagger file and using this Swagger file as the routing engine for your service. So the only thing that you have to do is to define Swagger files, the entry points for the Python methods that should be called when you are using this or that call, and that's it. It's really cool. It makes especially prototyping really fast, so, and easy. We have also the same project for Play to exchange the Play way of using root files. But yes, I think we still. I'm somehow very fast again, and I thought it's crazy. I thought I was not. Was I fast, guys? No. Was I boring? Okay, good. So then you have a lot of time to ask me questions.
Thank you, Valentine. Okay, so do we have questions? Yes, we do.
Hi, I got a question. It's about if you have so many independent teams and the bus in the middle, how can you get sure that the data is always matched and have the same keys and so on? So isn't it a huge mess of data and no one knows what it is?
We have experience in huge masses of data, yes. And we are trying to do everything to avoid this mess. And one of the tools to avoid this mess is the API guild. So we actually have the concept of guilds that are cross-team structures, and several teams, for example, the technology guild or API guild are actually curated guilds, so to say. So, for example, API guild is curated by our senior architect and his team, and the team contains many volunteers from different teams who actually volunteer to review the APIs that people describe. And I also have here, I think, I forgot to put it here. So actually, if you go to our GitHub page, we have our REST API guidelines published as an open source project. And there we are defining kind of the main principles that we want to, that the teams actually follow when defining the APIs. And it also includes the data modeling part. So the entities that you expose through the Swagger APIs, now it's called actually Open API Open API definition APIs, they should be consistent with the entities that actually are pushed into the data lake. What we it's not yet implemented, but on the roadmap for the event bus, it's also automatic discovery of these entities that are defined by the projects. So there we hope that the streamlined process of review of the APIs will help us to reduce the horror and chaos of data just being declared chaotically by everybody. So, did I answer your question? Yeah.
Yeah. When you distribute data on the database level, usually you run into the problem of dependencies. So how do you deal with changes? For example, you have data in a table, you use replication tools to replicate that somewhere else. You have a consumer, the consumer is not prepared for your database layout to change. And in an API, you can use different versions, you have blue-green deployment and so on. How do you deal with that on a database level?
We hope. So for now, this is on the level of prototypes. So we are kind of collecting this data now from several services only. But the idea is that we actually mark every schema that is published with a version, of course. And the whole idea of RESTful APIs is actually the same. Yeah? So you need to, if you're extending your entities, then you're usually extending them so that they are backwards compatible. It's more or less the same. I think these questions are answered by the RESTful principles better than by something else. I see you are not satisfied. We also have experience of a very consistent way of extending data entities in our Postgres infrastructure. Yeah, we collected a lot of experience there, and I will be really happy to show you what we have there. So if you will be interested. Yes, of course.
Right. I have a question. So you said several times that the architecture where each microservice has its own local database that streams an event log to the bus is not the right one, and you should be doing something else. Can you explain what should be something else and why it's a bad idea to do it this way?
Mostly, my problem with the approach is actually this this approach that I showed you. The problem with double write. So you have to, if you have your database as part of your application and you are not persisting data directly into the event bus, then you have the problem, where is the primary source of your, where is the truth? Is it in the event bus or is it in the database? And if the database doesn't support two-phase commits, you don't have even theoretical possibility to do it correctly and keep your data consistent. So that's why I think this is just the wrong architecture. And if you write data only to the bus and then have a small other service, actually, what does this database do? This database allows you to recover the state after the restart. So this can be done by actually replaying events from the bus if the snapshotting infrastructure is nicely built. And another thing is fast access to data. And in most cases, it can be used as a cache. Yeah, so it's kind of, in most cases it's a cache. So if you want your, if you need a cache, then build a separate service that extracts the data from the bus and builds this cache for you. That is not relevant to your actually business logic. But there are a lot of problems there as well, because, for example, locks and distributed locks and the concurrency issues have to be correctly addressed there. Yeah.
Do we have more questions? Well, just because it's you know.
So you said at the beginning that you're running everything in containers and you have the database inside the container, if I understand. How do you manage persistent volume with Docker? Do you have some kind of orchestration for this? Or?
First of all, I never said that we have databases in containers, but we do have databases in containers. And this is, our DBA team was swearing like seamen when building this thing into containers. But actually now we have a working solution for that. And yeah, it's a Patroni system. Yeah, no. One of the projects on the open source page for Postgres, for example, we have the appliances for Postgres, we have appliances for Cassandra, and you have to do a lot of additional trickery to really ensure that your underlying system will work correctly with your Docker. But I think the container is not the biggest problem there. It's just the AWS is the it is a system that you cannot trust, and this brings you into the situation where you cannot. So your disks that you cannot trust the disks. The only thing in AWS that you can trust is S3. With 11.9s, I think they have availability. So EBSs have, I think, weaker SLAs than some other systems there. So it's kind of this is just to make your life perceivably easier, but yeah, so you cannot build these systems, databases, trusting the EBS, for example. You have to build a cluster that is correctly running, and if you lose one of the machines, then your cluster survives it. So you shouldn't don't trust the system.
Do we have any questions? Are people wanting some break and a little bit of eat? Yes, okay, I think it's time to split. Thanks a lot for your wonderful talk.